Thanks everyone for coming out. So my name is Andrew Duch. I work at Jet.com, and I'm going to talk a little bit about how Jet.com went on a multi-year journey to move from running in one region to multiple regions, and some of the lessons that we learned along the way. So this is one of the quicker talks. I think we only have about 15 to 20 minutes. So real quick introduction. I am the tech lead for the cloud platform group at Jet. What is Jet? We're an e-commerce website really focused on helping you save money. There's a few important things you should know about our tech stack, I think, before we begin. One, we run entirely in Microsoft Azure. In no way is this a talk about Azure, but it's important to note because the concept of availability zones didn't really exist in Azure until relatively recently. So you'll hear me use the word data center and region interchangeably. Two, we use the event sourcing design pattern heavily at Jet. Again, this is not a talk about event sourcing, maybe another time, but it did influence how we architected for multiple regions, and you'll kind of see that throughout the presentation. And finally, we make heavy use of microservices at Jet as well. We've got thousands of them, and that also influenced our design. One small note, Jet was acquired by Walmart in 2016, so we're actually part of the larger Walmart Labs engineering family, which is really cool. So, not too long ago, July 2015, Jet.com launched. It was very exciting. We were, laser focused on launching. We launched in one Azure region. It was a very exciting time for me as an engineer to finally be part of something that actually got launched, got press. Very exciting. Less than 1 month later, we had some not so exciting press. If you are a site reliability engineer, this is probably like your worst nightmare. So in August 2015, we experienced our first major outage, and people noticed. Not only did the industry notice, not only did the press notice, but our leadership noticed. And they realized at that point that reliability is really, really important. So with Black Friday and Cyber Monday looming, our first ever, just 3 months away, it became a business imperative to move to multiple regions. And we knew that if we had a major outage during a holiday weekend, we might not exist as a business for the next year. So we decided to invest in building out a second cloud region. Let me explain why real quick, because there's a lot of different things we could have done to improve the reliability or resiliency of our system, right? We could have spent those 3 months just really focusing on making sure our systems were resilient within one data center, but there were a couple of reasons why we decided to go big and go multi-region right then and there. One should be pretty obvious. We wanted to be able to tolerate regional failure modes. No matter how resilient we made our systems run in a single data center, we still would never be able to tolerate a regional outage. Two, faster mean time to repair. So in the early days of Jet, like I said, we had this highly distributed microservices architecture. We didn't spend a lot of time focused on observability pre-launch. We didn't really have great tracing tools. So oftentimes when something would go wrong, we would be stuck scratching our heads and trying to dig through tons of different logs and services to really pinpoint what had actually failed, right? And so having a second region, if we could watch and say, hey, we see error rates rising in one region, but the other region looks healthy, we would have the option to have like a big red button to just say, all right, let's just shift all traffic over, and then we'll do like a root cause analysis and figure out what's really going wrong. And the final sort of big reason why we decided to do this, planned events. Obviously, we tried to avoid offline maintenance as much as possible. We try to use canary releases within a region as much as possible. But every once in a while, you're going to be faced with some sort of rollout or config change that is significant and serious. And having the option to at least take that data center offline or at least shift all traffic away, we felt was hugely advantageous. So what do we do? Well, like I said, we had 3 months. We asked every engineering team that was part of our sort of tier 1 flow to come up with a multi-data center architecture plan. And what did they do? They wanted to do everything. So they basically came back and said, well, it'll be really easy if you can just figure out how to replicate all of my data systems to the other region, and then all I have to do is launch my service there. So they wanted to replicate their caches, their Elasticsearch indexes, their source of truth systems, their Kafka messages. They wanted to get it all replicated because that would be really easy for them, they felt. Of course, it's not. So what we decided to do was basically establish a standard where we said, let's not replicate every data store. Instead, let's focus on replicating our source of truth data stores. So why do we do this? So we weren't even building a brand new database. We weren't building some brand new innovative file system. We were using a lot of off-the-shelf open source database systems. We were trying to leverage managed data services from Azure as much as possible. But with each of these systems, the designer of these systems at some point had to make some decisions and make some trade-offs around consistency and availability. And each of these data systems have their own little nuances about how they handle it. Understanding those little nuances takes time, it takes energy, and to really be able to test and validate all the failure scenarios of these different systems takes a lot of time. So we really tried to scope down the number of systems we had to replicate, and we said, let's replicate our source of truth. So this is where event sourcing really came in handy, because we actually had a source of truth data system. It's a database technology called Event Store, and we felt if we can just replicate this Event Store data across multiple regions, we can then project and hydrate all of these other data stores locally, right? So replicate our source of truth, and then we'll hydrate Redis cache or an Elasticsearch index or Kafka messages all locally within that region, and that really simplifies our architecture. So what we came up with for the first year, it's a bit of an eyesore, I apologize, was basically a chain replication model for Event Store. We wrote our own basically replication service, and we did asynchronous replication from our primary region to our secondary region. And then from there, we would project into all of these different data stores. Again, pretty easy to get up and running. There's actually a really great blog post from one of my coworkers who built this diagram. I encourage everybody to read it afterwards. It's a really cool example of how to do event sourcing across multiple regions. So from there, we moved to lesson number 2. Not every system needs to be active-active, right? So this first holiday was coming up. We had 3 months. The easiest thing to get up and running was basically an active-passive architecture. Why is that easy? Well, really all you have to do is make sure that you've got your data being replicated to a secondary region and available for when you need it. And then you need some way to either scale up or launch your services when you're ready to fail over. So implementation complexity, super low. We were able to accomplish it, maybe not easily, but we made it for that first holiday. But failover complexity is really high, right? Because now when we want to fail over, we have to do a very complex series of actions like making the secondary region the write master, shifting traffic, scaling up services in a secondary region. But the real issue was actually that because we had no live traffic going to the second region, we did not understand the health of that region before we failed over. So I can't tell you how many times we would go through this 20, 30-minute failover exercise. We get to the other region and realize, wow, Team X hadn't deployed their service there in 2 weeks, and now we've got all these other issues. So like I said, it got us through that first holiday, but we knew we could do better. So from there, our focus was really moving towards what I'll call sort of an active-active stateless model, where we actually have live traffic going to both regions. So we're just continuously validating the health of at least the stateless services in that region. And in 90% of cases, those transactions are staying within that region because they're hitting the Redis or the Elasticsearch or whatever other system you have there locally. And then only in a very few specific cases where we wanted to ensure we were always consistent, would we actually use a write master in a specific region and then just replicate back. So why not just do everything active-active? I'll kind of boil it down to 3 reasons, I suppose. One, time. Being able to re-architect our entire system in 3 months to make it active-active was just not feasible. Complexity. When making cap trade-offs about your system, oftentimes it's actually like a very domain or service-specific decision that needs to be made there. And so if you look at a gigantic architecture like Jet, there may be dozens or if not hundreds of these decisions that need to be made. And conflict resolution really requires a lot of thought. And like I said before, it's not like a blanket statement you can make for everybody. Every service really needs to think about those trade-offs. And finally, cost. Having hot data access in every region can become very expensive, and oftentimes it's not necessary, right? So we really focused on getting our Tier 1 services up and running in both regions, but taking a look at some of our Tier 2 or Tier 3 services that didn't have the stringent SLOs of our other ones, we did a cost-benefit analysis and decided yes or no about going multi-region with them. So I think the takeaway for me here was, we really tried to let the SLO drive the architecture decisions about when to invest in multi-region. Okay, lesson number 3. 3 is cheaper than 2. What am I talking about? Data centers. So we were running in one data center. The next logical step was to run to 2 data centers. And when we spun it up, we realized now that we actually had about 100%, we basically had about 100% waste of resources, because if we were to tolerate a data center going down, we need to have enough capacity in the other data center to support 100% of the traffic. If you move to a 3-region model and you still want to be able to tolerate just a single data center going down, you actually only need to scale each of those data centers up to 50% capacity of whatever your peak load is for that day. And so in this model, you're actually reducing the excess capacity in half. So you can actually continue to move further with this, 4 data centers, 5 data centers, but your returns do diminish over time. And that's really because there are some fixed costs about having multiple data centers, even in the cloud, right, where it's not our physical hardware. Just getting the data replicated there so it's ready if we need it costs some money. But there are other benefits as well. You could then potentially tolerate 2 data centers going down. For us, 3 seemed to be the sweet spot of cost and complexity and what was available for us in the cloud at that time. Okay, lesson number 4, practice, practice, practice. We did all this work. How do we know we can actually tolerate a regional failure? So at Jet, what we do, we run traffic failovers on a weekly, sometimes even daily basis. And these are pretty simple exercises. We will use our edge cloud provider, just route all traffic to one region. Pretty quick, takes less than a minute. And this just ensures that we have the full capacity we need in all of our data centers to handle the amount of traffic in case one goes down. The next sort of level of complexity is to actually do storage layer, more disaster recovery style exercises. We do this monthly. They do take some time to run. There's no impact to the end user when we run these exercises, but it does eat up engineering time. We found that if we delayed these exercises beyond 1 month, oftentimes systems would drift and we wouldn't feel confident we were actually ready to execute them if we needed to. But that's really not enough. The first time we did a storage failover, we were patting each other on the back. We shifted all traffic. We had all storage moved over to the secondary region. And we said, let's cut the replication link between east and west. Let's really prove this works. So of course we did. And we had all kinds of issues. What we found is that the engineering teams would say, yeah, I'm running in both regions. My service is running there. But they would have 20 dependencies. And only 18 of their dependencies were actually running in that secondary region. And when you took down that link, they would go, oh, I forgot. Yeah, I was talking to this other service that only exists in East, and I don't have a way to gracefully degrade when it goes down. And so for us, it was really important to make sure that we're breaking those regional links and actually being able to hold teams accountable that they've really thought through all of the dependencies they may have in a region. And the final lesson, failover automation needs to scale. So like most startups, our first failover automation was really just a bunch of scripts that we would run. It wasn't particularly elegant. It got the job done, but it required a ton of operator expertise. And when things would go wrong, it would require a ton of manual intervention. So it worked okay. It worked okay if you were only doing this for 1 or 2 systems. But once you start thinking about your entire architecture and the dozens and dozens of different systems you have, it's really hard to scale that. It's really hard to keep these patterns consistent. So what we decided to do is we actually came up with a custom tool that would fully automate failover. And what we did in that case is, instead of just moving systems from point A to point B, we actually came up with this a state machine design where each system, when moving from point A to point B, the system would also check all of the global states of all the other systems in the data center. And so this would prevent us from getting into invariant situations where we kick off a failover and it's progressing and we think everything's going well, but some other system has failed in the back end and we don't really know about it, right? And the worst thing that can happen in an event-sourced system is that you have 2 write masters and we have divergence and we have all kinds of crazy stuff we have to deal with after the fact. So it was really important for us to be able to failover safely. In my opinion, I think the ultimate goal of where you want to get to is actually to let these failovers happen at the platform layer. Doing any kind of external failover coordination can get really tricky. You have to account for so many different edge cases that could be happening. And if you can let really each layer of your stack understand when it's necessary to fail over and build that directly into those platform layers, you're going to have a much better time when trying to do these types of exercises. Cool. So with that, I think I have about 5 minutes for Q&A, and I just want to say that this is the work of a lot of different people at Jet, not just me. Thanks.
Hi, Andrew.
Hey.
So I have a question for you. When you broke the replication link between the two places, right, and teams had dependencies on certain regions, you said something like, and now we can hold the teams accountable. Can you expand on that? How did you actually hold teams accountable? What was your approach? Because there's a variety of different approaches in different companies to hold teams accountable, but I'm curious, how did that actually work inside of Jet?
Yeah, so in that case, if their system broke in that scenario, potentially they're most likely breaking their SLA because their service is down. And at that point, it really just becomes a production incident like any other. And as part of the postmortem, we will identify action items to make sure that they've worked through whatever that dependency is before the next failover exercise. In most cases, as soon as possible, it really becomes their top priority. There's more subtle cases where, sometimes it's about them bringing their dependencies over. In other cases, it's more about saying, let's just gracefully degrade in a certain way. Maybe we don't have 100% of the functionality of the service, but we can offer 75% of it if we don't have this other dependency. So we'd really try to work with the teams to understand what the best course of action was there. Is that it? Cool. Thank you, everyone.